This is the first of two practice problem review videos I'm going to make regarding the SD plus rules, those practice problems. Now that we have all of the rules on the table, the basic 11 SD rules plus the 3 rules of inference and all of those rules of replacement. In this video, I'm going to go over 3 problems from page 222 and 223. That's problem 2A, 2C, and 2E. The next video I'm going to make is going to be going over some theorems using these SD plus rules. So let's go ahead and get started with 2C. Right here, what we've been asked to derive is y if and only if z, and we have these 3 premises. Now, if we were using just the basic SD rules, we'd have to do a biconditional introduction using 2 subderivations, and with all of these negations, we definitely have to do some negation introduction and negation elimination type stuff. But since we have the SD plus rules, we can do this without any subderivations. So the first thing we want to notice is that we're going for a biconditional. And if you look at our rule of replacement equivalence, you should have your rule sheet out. It's hard for me to put all these rules on the PowerPoint while going over problems. But if you look at equivalence, one thing we can do to get a biconditional is to get 2 material conditionals, one each way. So what I'm going to try to do here is get if y then z and if z then y. Getting if z then y is really easy. It just takes one step. Right on line 1, we have if the negation of y, then the negation of z. We have this rule transposition, right, that allows us to flip a material conditional that has 2 negations and remove those negations. So on line 4, we can get if z then y using transposition from line 1. So now we need to get if y then z. Now we know that we have a negation of z here and a negation of y here. So if we can, if we can put these 2 together, then we can use transposition again. And thankfully we have a rule that lets us do that, right? We have the rule hypothetical syllogism that tells us that if we have one material condition, if we have 2 material conditionals where the consequent of one is the exact same as the antecedent of the other, then we can kind of put those together, cutting out the middleman. So we can get if the negation of z, then the negation of y by hypothetical syllogism from 2 and 3. Because we have this same matching part, right, from the consequent of 2 to the antecedent of 3, we can create this new material conditional that cuts out that middle part. So now that we have these with the negations, right, we can do the same thing again. We can use transposition and flip them around. So now we have if y then z. So now we need to put those together, right? If we want to use equivalence, we have to have if y then z and if z then y together. So that's the next step on line 7. We're going to use conjunction introduction from lines 4 and 6. So now that we have those together, we can use equivalence, right? Equivalence tells us that if we have any 2 sentences, if P then Q and if Q then P together, right? Here we have if Y then Z and if Z then Y, then we can change that into the logically equivalent biconditional. So that's this first problem. These next 2 problems are quite a bit more difficult than anything I'll actually ask you to do on the exam, but working with these problems and figuring out how to do them will make it so that the exam problems are easier for you, which is important, right? You have a limited amount of time to do 5 derivation problems. So if you get comfortable with these hard problems, the problems on the exam will be easy to do in the amount of time. So I know what I'm trying to get here is a material conditional. So as we've done when we just had the SD rules, as we do all the time, I'm going to start with a premise for conditional introduction. I've got I, and what I'm trying to prove is the negation of D. So the first thing I can get with I is the consequent of 2, right? Is a conditional elimination from 2 and 3. So now I have, it's not the case that F and D. What we've got to do here is try to figure out a way to get not D out of this. So we can use De Morgan's and push that negation through the conjunction, which adds the negation, push it through the parentheses, which adds the negation to F, adds the negation to D, and flips that conjunction to a disjunction. So now we've got not F or not D. So now we need to try to figure out how to get not D by itself. One way to do this using the basic SD rules would be to do a disjunction elimination, which would take two subderivations, right? One side we'd assume not F, and then try to get not D from that. And then the other one would be really easy. We would just assume not D and then repeat it to get not D from itself. But I want to show you how to do this without using that subderivation rule. So the rule that I want to use, because I have a disjunction here, is going to be disjunctive syllogism, right? If I can get the negation of not F, so F with two negations on front, then I can use disjunctive syllogism to know that not F is false, and it'll let me get not D by itself. But that's going to take a couple of steps, right? The only place I can see we can get F by itself from is buried inside this conjunction, which is inside this disjunction on line 1. So I need to try to figure out how to get F and G out of this disjunction, and we're going to have to use the same strategy, right? We're going to have to use disjunctive syllogism. So we need to try to get the negation of not H and not I. I know that was a lot to kind of lay out the plan, but let's just get started and I'll show you how to do it. So we want to get the negation of not H and not I, and we have I by itself here. So what I'm going to do is I'm going to add a double negation to I, right? The double negation rule lets you tack on two negations to any sentence you want. And now I'm going to use a disjunction introduction to have the negation of H or the negation of I. So now we've got a disjunction that has a negation attached to each disjunct. So we can use De Morgan's in the reverse way, right? The reverse of the way that we used it on line 5. And we can get, it's not the case that H and I, right? We pull a negation off each of those disjuncts, flip the disjunction to a conjunction, and put that negation outside of the parentheses. So now we have, it's not the case that H and not I. And then on line 1, we have F and G or H and I. So we can use that disjunctive syllogism rule, right? We know that one of the disjuncts is false, so we know that the other disjunct has to be true. So now we have F and G. Now, remember what we're trying to do is get not D by itself out of this disjunction on line 5. So what we need from that is F. We can get F by conjunction elimination from F and G on line 9. And the important thing to remember here, which I believe I've mentioned already, is that with disjunctive syllogism, we can't go straight from F to the disjunctive syllogism up here, right? Because even though we know that if F is true, that makes the negation of F false, we have to have the negation of that disjunct, right? Not just something that's logically equivalent to the negation of that disjunct. So we have to do a double negation on F. Now we have the negation of F, and then we have the negation of F as our disjunct on line 5. So finally, we can use disjunctive syllogism and get the negation of D from that negation of F on line 11, and that disjunction that says either the negation of F or the negation of D on line 5. So this problem was a lot and used several of our SD plus rules, which is why I thought this would be a good problem for you to try and to show you how to do this. So now we've just got the very simple last step, right? We assumed I for conditional introduction. We proved the negation of G. So now we can go back to our main scope line and write down if I, then the negation of D using conditional introduction for that whole subderivation, lines 3 through 12. All right, so on to the last problem. This is 2E. We're trying to derive I or H from these three premises, right? If F, then if G, then H. if the negation of I, then F or H, and if F, then G. So this isn't a material conditional. We can't take the strategy that we always take for doing this. So I'm going to take my second favorite strategy, which is when I don't see how to do something, I'm going to assume the opposite of what I'm trying to get. So I'm going to assume the negation of I or H, right, the negation of that in parentheses, as a premise for negation elimination. So now I've got to start working with this and try to find a contradiction. There's a couple of ways you can do this problem, but I'm just going to work it through. The first thing I know is that I have a negation outside of a disjunction, which means I can use De Morgan's and turn it into something a little bit more useful, right? I can turn it into the negation of I and the negation of H. Now I can pull this apart. So the first thing I see when I look back at my premises is that I can use the negation of I with line 2. So I'm going to pull the negation of I out by itself, right? That's conjunction elimination from line 5. And then I can use it to get F or H via conjunction or conditional elimination from lines 2 and 6, right? I have the negation of I by itself on line 6. And if the negation of I, then F or H on line 2. So now I see that I have F or H. I also have the negation of H in 5, right? So I'm going to take that negation of H out by itself. And this is just kind of what my instructor, Dr. Rawling, calls following your nose, right? We're just taking what we have and playing with it to see what we can get. On 7, I have F or H. On 8, I have the negation of H, so I know H is false. So I can use disjunctive syllogism, right? We know we have this disjunction. We know one of the disjuncts are false. So we can use disjunctive syllogism to get the other disjunct F by itself on line 9 from lines 7 and 8. And now I have F, which is the antecedent of both the conditional on line 1 and the antecedent of the conditional on line 3. So now I'm just going to use conditional elimination and start pulling things out. So I know I can get G, that's conditional elimination from the premise on line 3, if F then G, and F on line 9. And I can get if G then H, that's the consequent of line 1, where again that antecedent is F. So now I've got G and I've got if G then H, so I can get H by conditional elimination again from lines 10 and 11. And now if you look, we have the negation of H on line 8 all by itself. And then we have H without the negation on line 12. That's both inside the subderivation. So we've found our contradiction by just kind of following the different steps we could take using these premises. So we've got the contradiction, which means we can end our subderivation and go back to the main scope line and write down I or H without that negation. Using the rule negation elimination from premises 4 through 12. So again, this was a bit of a hard problem. This is harder than anything I'm going to give you on the exam. The exam will have problems that can be done in fewer steps than this. But I did want you to see how these rules work, how you can go back and forth between them, that kind of thing. So again, I'm going to make another video where we do some theorems using the SD plus rules. But that's it for this one.